Welcome to Space and Beyond. Our universe is vast and ancient, filled with both creation and destruction. But nowhere is this cycle more evident than right here on Earth, our dynamic blue planet. Let's take a closer look. Our planet has experienced 5 major mass extinctions throughout its history, with some scientists suggesting we may be entering a 6th. Today, we journey through time to explore these planetary resets and discover how events beyond our atmosphere have shaped life on Earth. Life on Earth has been nearly wiped out 5 times in what scientists call the Big 5 mass extinction events. At least 75% of all species vanished. But these weren't simply tragic endings. They were also beginnings, creating evolutionary opportunities that eventually led to the world we know today. Let's travel back in time, over 440 million years ago, to witness Earth's first great dying. The first mass extinction event, the Ordovician-Silurian Extinction, 445 million years ago, an unrecognizable planet. Most life exists in oceans, and bizarre creatures dominate the underwater landscape. The continents are largely barren, with only the earliest plants beginning to colonize the land. Then, a cosmic influence triggers disaster. Earth's orbit changes, potentially due to gravitational interactions within our solar system. Our planet rapidly cools, and massive glaciers form across the supercontinent Gondwana. Sea levels plummet by over 100 meters, destroying shallow marine habitats. Ocean chemistry changes as cold water absorbs more carbon dioxide. In 2 pulses of extinction, approximately 85% of marine species vanish forever. When the ice finally retreats, the survivors emerge into a transformed world, one they would eventually repopulate with new forms of life. 375 million years ago, the Late Devonian mass extinction. By the Devonian period, life has rebounded spectacularly. The oceans teem with fish and complex reef ecosystems. On land, the first forests appear, and primitive amphibians begin exploring the shores. But over a period of millions of years, multiple extinction pulses decimate this flourishing world. The worst, the Kelwasser event, wipes out over 70% of species. The causes remain debated, but evidence points to a combination of factors: massive volcanic eruptions in what is now Siberia, global cooling triggered by the spread of land plants that extract CO2 from the atmosphere, ocean anoxia, deadly oxygen-depleted zones in the seas. Some scientists suggest an extraterrestrial connection. Evidence of multiple impact craters date to this time. Whatever the cause, the mighty Devonian armored fish and spectacular coral reefs largely disappear, making way for the rise of sharks and the first reptiles. 252 million years ago, the Permian-Triassic Extinction. The most devastating extinction in Earth's history deserves its ominous nickname, the Great Dying. In this catastrophe, approximately 96% of marine species and 70% of terrestrial vertebrate species perished. The cause? Deep within the planet, massive magma plumes rise to the surface, triggering unprecedented volcanic activity. Enormous volcanic eruptions in Siberia, the Siberian Traps, spew lava across an area larger than Western Europe. For thousands of years, these volcanoes pump carbon dioxide and methane into the atmosphere, dramatically altering Earth's climate system. Global temperatures soar by 10 degrees Celsius. The oceans acidify and lose oxygen. Toxic hydrogen sulfide bubbles up from the depths. On land, acid rain falls, and the ozone layer weakens, exposing life to deadly ultraviolet radiation. The world that emerged from this disaster was so depleted that scientists call the early Triassic period the coal gap, a time when so few plants existed that no coal deposits formed. Cosmic-scale volcanic activity reset the evolutionary clock. From these ashes would rise the age of dinosaurs. 201 million years ago. Welcome to the Triassic-Jurassic era. As life slowly recovered from the Great Dying, another catastrophe struck. At the boundary between the Triassic and Jurassic periods, approximately 80% of species vanish, including many early dinosaur relatives and large amphibians. The culprit appears to be another episode of massive volcanism, this time associated with the breakup of the supercontinent Pangaea. As the Atlantic Ocean begins to form, enormous flood basalts create what geologists call the Central Atlantic Magmatic Province. These eruptions release massive amounts of carbon and sulfur dioxide, driving rapid climate change. In the oceans, groups that survived the Great Dying finally disappear. But this extinction had a silver lining for one group: dinosaurs. With many ecological competitors eliminated, dinosaurs rapidly diversify and dominate the planet for the next 135 million years. The fifth mass extinction event, 66 million years ago. We now entered the Cretaceous-Paleogene era. The most famous extinction event demonstrates the direct cosmic connection to Earth's biological history. 66 million years ago, dinosaurs rule the land, giant marine reptiles patrol the seas, and pterosaurs soar through the skies. Then, catastrophe arrives from space. An asteroid approximately 10 kilometers wide, about the size of Mount Everest, slams into what is now the Yucatan Peninsula in Mexico at 20 times the speed of a bullet. The impact releases energy equivalent to 10 billion Hiroshima bombs, triggering a global tsunami over 100 meters high. Worldwide wildfires ignited by re-entering ejecta, creating a global firestorm that devastates forests and grasslands across the planet. An impact winter as dust blocks sunlight for years, plunging Earth into darkness. Plant life withers without photosynthesis, collapsing food chains worldwide. Acid rain from vaporized rock poisons land and water alike, destroying ecosystems and corroding the bones of creatures caught in the deadly downpour. When the dust settles, all non-avian dinosaurs have vanished, along with approximately 75% of all species. Small, adaptable mammals survived this catastrophe, eventually evolving into primates and, much later, humans. Fast forward to 75,000 years ago, the Toba Catastrophe. More recently in Earth's history, a supervolcano eruption at Lake Toba created a global disaster that nearly wiped out our own species. This eruption ejected an estimated 2,800 cubic kilometers of material, thousands of times larger than the 1980 Mount St. Helens eruption. The resulting volcanic winter may have reduced global temperatures by up to 15 degrees Celsius for years. Some genetic studies suggest the human population crashed to perhaps as few as 3,000 to 10,000 individuals worldwide. While not classified among the Big Five mass extinctions, the Toba Catastrophe demonstrates how vulnerable even our technologically advanced species remains to Earth's geologic forces. The near future. Are we ready for the next mass extinction? Today, many scientists warn we may be entering a sixth mass extinction, the first triggered not by asteroids or volcanoes, but by a single species, humans. Current extinction rates appear to be 100 to 1,000 times higher than the normal background rate. Habitat destruction, climate change, pollution, and overhunting threaten countless species. Unlike previous extinctions, we have the knowledge and technology to mitigate this crisis. The question remains, will we use these tools in time? Mass extinctions reveal a profound truth. Life on Earth exists in a delicate balance, influenced by forces both terrestrial and cosmic. From asteroid impacts to the volcanic activity driven by Earth's internal dynamics, our planet's history is written in part by events beyond our atmosphere. As we at Space and Beyond continue to explore our universe, we gain perspective on our own fragile existence. Life persists through catastrophe. Each extinction, while devastating, created opportunities for evolutionary innovation. Our journey through Earth's greatest extinctions reminds us how fragile yet resilient life can be. What cosmic challenges await humanity's future? Join us for our next exploration as we continue to uncover the universe. Subscribe to follow and share your thoughts below. Until next time, keep looking to the stars.